This question introduces itself straight away. It's telling us to use small angle approximations. And those are given in the formula book. So I've written one on the side that cosine theta is approximately 1 minus theta squared over 2 when theta is measured in radians. So part A is a show that question. Show that quadratic in cosine is approximately equal to 8 minus 5 theta squared. Okay, so let's just start doing that straight away. We have to start with the left-hand side. We start with 1 plus 4 cos theta plus 3 cos squared theta. That's what I might call the exact function. We're going to bring our approximations into that, so that's going to be roughly equal to 1 plus 4. Now cosine theta gets replaced with 1 minus theta squared over 2 plus 3. Now cosine squared theta, so we've got our approximation for cosine, and that's going to get squared. And our approximation again is 1 minus theta squared over 2. Now we just need to expand and simplify these things. So we've got 1 plus, expand these brackets, 4 multiplied by 1, minus 4 theta squared over 2, so that's minus 2 theta squared, plus 3. This bracket needs expanding, it needs squaring. 1 squared is 1. Minus theta squared over 2 minus another theta squared over 2 is minus theta squared. And then there's going to be a positive theta to the power 4 over 4 term. Now because theta is small, theta to the power 4 over 4, we can neglect that, we can ignore that as theta is small. Bigger and bigger powers of theta make smaller and smaller numbers. Okay, and we're only aiming for a quadratic approximation. So let's look at that. We've got 1 plus 4 minus 2 theta squared plus 3 times 1 3 minus 3 theta squared, which is 1 plus 4 plus 3 is 8 minus 5 theta squared as required. Okay, so we've achieved the show that in part A. Adele uses 5 degrees as a test, so she substitutes that in both sides separately. On the left she gets 7.9, on the right she gets negative 117. Something is seriously wrong. What is the mistake? The mistake is she's worked in degrees, so these approximations are only valid for theta in radians. Approximation only valid for theta in radians. And you might want to emphasize she's substituted 5 degrees. Okay, that's the mistake. So how can this be used as a good approximation? Well, the 5 degrees needs to convert to radians, and 5 degrees, remember in general, pi radians is 180 degrees, so 5 degrees is pi over 36. Show how that can be used to give a good approximation, so I guess they want us to actually do that. So what I would do is put pi over 36 in my calculator so that I can use the answer button. The left hand side is 1 plus 4 cosine answer plus 3 cosine of answer, and then we need to get that squared because it says cosine squared. So on the left hand side I get 7.9999, very close to being 8, and on the right hand side, so we're substituting, so let's put pi over 36 back in as our answer so that we've got that to play with. We're substituting that into 8 minus 5 theta squared, so 8 minus 5 answer squared is 7.96, and yes, therefore it is a good approximation there.